Okay, we're going to cover chapter 2.9, which is solving linear inequalities. And this is just like solving equations, except we have to just be careful with a couple things. And then we're going to graph them. And so it's a little different than maybe what you've learned before with some of the notation. And then we're going to learn interval notation. So just a brief summary. An inequality relates algebraic expressions with less than, greater than, less than or equal to, or greater than or equal to. So a parenthesis indicates that an endpoint is not included. So we're going to use a parenthesis. You might have learned instead of parenthesis we would use an open circle. We're not going to use that anymore. A bracket or a square parenthesis is when the endpoint is included in the solution. And you used to use those with a filled-in dot maybe on the graph, but we're not going to use that anymore. You always use parentheses when you're talking about negative infinity or infinity. And always the set of all real numbers from negative infinity all the way as far as you can go to positive infinity always has parentheses. What's really key is that when you multiply or divide anywhere in the equation, the inequality flips directions. All right, so we're going to try and combine all that into one. So let's look at the first one. This says all the values on the number line are bigger than or equal to 3. So all I need to do is graph the 3, and anything that's bigger than 3, my arrow goes that way, 4, 5, 6, and all the numbers in between. So instead of putting a closed circle here, we're going to put a bracket because this means equal to, goes this way. So this says all the numbers on the number line are bigger than 3 or equal to 3. And our bracket always goes the same direction that our arrow goes. Okay, let's look at the next one. All the values on the number line are less than 8. We only need the number 8. If you want to make your number line all fancy and put a bunch of numbers, that's okay. So what values are less than 8? All the ones to the left. And since it doesn't equal 8, I put a parenthesis. Again, we might have learned that you would put an open circle, and you'll see some videos like that, but we prefer the parenthesis or the square bracket. Okay, now let's look at the other one. Well, this is kind of confusing. Negative 4 is greater than x. Well, I know I'm going to need negative 4, so I'm going to rewrite this where the variable is always on the left. But when you do that, you have to be very careful. So I'm going to switch the x and the negative 4. If I switch those two, I have to switch this. This inequality is pointing to the x. It still has to point to the x. So all the values on the number line are less than negative 4. So that's all of those values. And again, we put a parenthesis because if I put a 4 in there, or negative 4, it doesn't work. Okay? So that's how we graph. Okay, so now let's do some where we solve them, and we also put them in interval notation. So we're going to solve it just like an equation, pretend that there's an equal there instead of the less than. I always try and get my variable on the left, so I can, my variable will be on the left, and then it's easy for me to understand the inequality. So I'm going to subtract 7x from both sides. I get negative 1 plus x is less than 2, and now I would add 1 to both sides. X is less than 3. I'm going to graph it. I need a 3. All the values on the number line are less than x. That means, less than 3, so it's that way. There's no equal sign, so I know it is a curved or parenthesis. When we write interval notation, we write the solutions that are graphed. What numbers work? And so anytime you work with inequalities, you're going to get a bunch of numbers that will work. So you can see there's an a large amount of numbers that work. We always write our interval notation coming from the left, and we stop wherever we need to. So all of the values from negative infinity to 3 work. This has a parenthesis, so I use that. That tells me that the 3 is not included. And anytime we use a negative infinity or positive infinity, it's always a parenthesis. Okay, let's look at the next one. Let's divide by -2. Okay, there's a thing that we have to watch for. Anytime we multiply or divide by a negative, we have to flip the inequality. So r, now instead of greater than, is less than 6. So let's graph. We need the 6. All the values on the number line are less than 6. That's all of those. It doesn't include 6. And we need a parenthesis. Okay, again, we come from the left. What value satisfies? If I picked any of these numbers and plugged them in, it would work. So obviously a lot of the negative numbers would work. So I'm coming from negative infinity and going to 6. This has a parenthesis. It doesn't include 6. And we always put a parenthesis around negative or positive infinity. Okay, let's look at another one. Okay, we're going to solve this like an equation. Remember, we undo addition and subtraction first. So I'm left with -2n is less than or equal to -3. Nope, it's not 3. It is 6. So that will be negative, I'm subtracting 3, so it's just going to be 6. Okay. Okay, I'm going to divide by -2. And again, now I divided by negative, so the inequality is going to switch or flip. N is greater than or equal to -3. Okay, so I need a -3. All the values on the number line are bigger than -3. It does include 3, so I have a square bracket, or we call that a hard bracket sometimes. Okay, so again, I'm coming from the left. The first value that satisfies this equation is -3, and all the values to positive infinity work. Again, when we use the infinity sign, it's a parenthesis. This one has a square bracket, so we're going to do that. All right, so this is a really long one, but we're still going to solve it. So we're going to do everything on the left. I get 10k plus 15. Distribute my -2. Distribute my -2. Distribute my 3. And again, we combine like terms on both sides, and then we start our adding and subtracting. So I get 10k and 2k is 8k. 15 plus 16 is positive 31. Is greater than 6k plus k is 7k. 12 minus 2 is 10. And again, I'm going to subtract the 7k from both sides because I like my variable on the left. I think it's easier to understand. Subtract 7k. I get k plus 31 is greater than 10. I'm going to subtract 31 from both sides. K is greater than -21. You see that I didn't change the inequality here because I'm just subtracting. I'm not multiplying or dividing. So I need -21. All the values on the number line are bigger than -21. It does not include 21, so I need a parenthesis. Again, I come from the left. The first value that satisfies it is -21. It goes to positive infinity. We always put that around the infinity or negative infinity. It does not include -21, so that is my interval notation. So if you have any questions, please email me.